Today my topic of discussion is number one, how do we construct or how can we construct a different random variable out of two given random variables. This is number one. Point number two, we are to find the joint probability distribution, of two random variables. And number three, we will study the process of calculating expectation, and we will see how do they behave in the domain of bivariate distribution. Okay, so these are the three things that I'm going to discuss in today's class. And to start with, let us discuss the point number one first of all. So here we are going to consider two ideal dice. So first of all, let us consider two ideal dice which will be thrown together simultaneously. Okay, and if I do so, you know that you are going to get 6 into 6, that is 36 outcomes all total. So I'm going to tabulate all the 36 outcomes first of all. Before that, I'm going to define my random variable in the following manner. So define random variable. And under this section, I'm going to consider two random variables. One is x1 and another is x2. What are the meanings of these random variables? The number x1 represents the number which will be shown on the face of the first dice, and x2 will give you the number of that will be shown on the face of the second dice. And we'll construct the sample points in the following manner. First of all, we consider x1, that is, we are going to put values over there corresponding to the first dice, and then I'm going to put x2 where I'm going to put the value of the second dice. And now you know very well that what would be the sample space. But since I'm going to construct a new random variable out of this, first of all, we are going to write the sample space so that we can take help from there when needed. So with respect to the given example, the sample space looks like this. So let me take some time to write all the outcomes. And then for the second row, we have this. So I have taken the pain of writing all the 36 outcomes, and now I'm going to define a new random variable in the following manner. My new random variable will be y, which will count the max of these two values, x1 and x2. Okay, and you know that if I try to apply this random variable to the given set of outcomes, then for this point 1 1, the max value will be y equal to 1. For these points, the max values will be y equal to 2, y equal to 3, y equal to 4, and so on. So you can very well understand what will be the max values in this particular case. Okay, so this is my new random variable. So I'm defining it in the following manner. Now, once I define the new random variable, what I'm going to do is that I'm going to consider a bivariate distribution where we are going to take two random variables. One is y and another is x1. So my new bivariate distribution under consideration is y and x1. And to know the bivariate distribution about a pair of random variables, what we need to find out is the probabilities. If we know the probability distribution of a random variable, we know the random variable, we know the system. So if we have a bivariate random variable, only if we know the values, then the system is not known. But if we have the probabilities associated with the values, or the pair of values, or the triplet of values in case of trivariate distribution, then we can say that, yeah, we know the distribution, we know the system. So my first argument in this particular case is y, which is the max of x1 and x2. And my second argument in this case is the x1, which was the first argument in the pair x1 and x2. So I'm going to prepare one chart on the next page, and you can take the screenshot of this page, because otherwise to write it in your copy will take some time. I'm going to prepare one chart, one bivariate table, in which I'm going to calculate the probabilities associated with this random variable yx1. Now, the probability distribution associated with yx1 will be studied. For this, I'm going to prepare the table first. So this is my y, and this is my x1. I will read the column first, and then I'm going to read the rows. Corresponding to the columns, I'm going to write all the possible values of the maximum of the random variable y. So these are the possibilities. And similarly, the random variable x will have the same possibilities from 1 to up to 6, because both the random variables are associated with one particular dice. Now I'm going to write the probability. The probability, now what this particular random variable is saying. When I'm writing the random variable pairwise, when I'm writing y comma x1, it means I'm going to count the maximum of x1 and x2. First of all, I'm going to see what is the value of the max of x1 and x2. And with respect to this value, what is the what was the argument, or what was the value of the first random variable? So when we talk about 1, to be the value of y, corresponding to which the value of x1 will be 1. Now you look at the previous table. If I consider in this particular case, the maximum of 1 1 came out to be 1. And with respect to that, the first argument, or the value of x1, was 1. And there is only one possibility. There is only one possibility in which it happened, that is 1 1 1. And therefore the probability for this particular case is 1 by 36. Now, when we consider the max of this x1 and x2 to be 2, now the max can appear, this maximum can appear if we consider this argument, if I consider max 2 and the value of x1 to be 1, you see that there is only one possibility, that is this one. If we have the argument 1, 2, the max can be 2 and the value of x1 is 1. So that value will also be 1 by 36. But if we consider the second one, that is 2, 2, in this case, you see the max is 2 and the value of the first random variable x1 is also 2. But there is another possibility, which is 2, 1. So when we consider the max y equal to 2, and at the same time, the random variable x1 is going to have the value 2, there are two possibilities, 2, 1 and 2, 2. If we consider this pair 2, 1, then also we are going to get the maximum as 2. If we consider this pair 2, 2, then also we are going to get the maximum as 2. So in this particular case, we are going to get the probability as 2 by 36. But you see that what will be the values in this particular case, in this particular column? Now, maximum is 1, but the first argument, that is the value of random variable x1 is 2, 3, 4, 5, 6. This is not possible. When the maximum is 1, the first argument cannot be 2, 3, 4, 5, 6. Otherwise, the maximum couldn't have been 1. So therefore, it is quite obvious that the probabilities of these parts will be 0. Okay. Now, similarly, if I look at the chart, then similarly we can find the other points also. That is the maximum when the maximum is 3, but the first argument of x1 is 1. This probability is 1 by 36. For this case, it is 1 by 36. For this case, it is 1 by 36. For this case, it is 1 by 36. So similarly, we are going to get 1 by 36 for the first row. For the first row. And if I consider this one, the maximum is 3, but the first argument of random variable x1 is 2, that is also only one case, which is 1 by 36. So row wise, we are getting 1 by 36 here also, 1 by 36 here also, 1 by 36 here also, and 1 by 36 here also. Just look at this. Only single possibilities are there in each of these cases. But when we consider the 0.33, then there are 3 possibilities. That is, when we consider the max of y to be 3, there are 3 possibilities in which this can happen. It can happen in 3.1, it can happen in 3.2, it can happen in 3.3. If I consider the max of y to be, the maximum of x1 and x2 to be 4, there can be 4 possibilities. If we consider the max of x1 and x2 to be 5, there can be 5 possibilities. And for the last one, there will be 6 possibilities. So in this manner, we can immediately say that the diagonal elements, and let us write the diagonal elements with different color. Okay, so let us write the diagonal elements with different color. You will understand it properly. So it is 1 by 36. This is 2 by 36. This will be 3 by 36. This will be 4 by 36. This will be 5 by 36. And the last one is 6 by 36. So for all the diagonal elements, you are going to get these values. And in this row of 3, 4, 5, and 6, the rest of the values will be like this. You can just check in a similar manner that we are going to get the values in the following order. Okay. And the remaining part of the chart will be having probability 0. So it has got a wonderful triangular shape in the following manner. So my bivariate distribution construction is partially done. Now, whether I have done it correctly or not, that can be tested by calculating the marginal totals with respect to rows and marginal total with respect to columns. Okay, so if I consider the marginal total of the first row, and let us name it to be the first row. Actually, my alignment is missing. This particular row is aligned to this. This is aligned to that. This is aligned to that, and so on. Okay, so if I consider the marginal totals of the first row, this is 6 by 36. Marginal total of the second row is 6 by 36, and so on. For each row, the marginal total is 6 by 36. 6 by 36. And what about my marginal total with respect to column? So we get marginal total as 1 by 36, 3 by 36, 5 by 36, 7 by 36, 9 by 36, and 11 by 36. Now, if I calculate the marginal totals, total of the marginal total, if I calculate the total of the marginal totals by taking these marginal totals which have come with respect to rows, you are going to find the total probability as 1. And here also, the total probability needs to come as 1. Let me check. That is also 1. So once we get the total of all the marginal totals, column wise and row wise, to be 1, that means the probability distribution that we have constructed is correct. Now, the second part, of the question has been the second part of the question or the discussion have been done, that I needed to discuss how to construct a probability distribution, a joint probability distribution corresponding to 2 different random variables. So construction of the random variable is over. The joint probability distribution of the new pair of random variables is over. Now I'm going to calculate a few things related to this particular table. So this is my table 1, or you can consider this to be your table 2 and this to be your table 1. So my table 1 job is done. My table 2, I'm coming to the section which is table 2, and for this table I'm going to calculate a few things. First of all, I will calculate the expectation of the random variable y. Then we'll calculate the expectation of the random variable y square, and then we shall calculate the expectation of the random variable vy. And we know that the variance of y is defined to be expectation of y square minus expectation of y whole square. And this is these are the quantities that I need to calculate. Okay. Now I'm going to do you can take the image of screenshot of this particular page. I can do the calculation in the next page. First of all, if we need to find the expectation of the random variable y, then the point is that whether I should consider these probabilities, these probabilities which have been written in this column, or these probabilities which have been written in the rows. The answer is, to calculate expectation of y, we need to consider these probabilities, because all these probabilities that is written over here, these are corresponding to the columns, where the column values are actually associated with the random variable capital Y. So to calculate the expectation of y, and we know that y has the possible values. What are the possible values of y? 1, 2, 3, 4, 5, 6. These are the possible values. The expectation of y will be 1 into 1 by 36 plus 2 into 3 by 36 plus 3 into 5 by 36 plus 4 into 7 by 36 plus 5 into 9 by 36 plus 6 into 11 by 36. And then you can easily calculate the value that you are going to calculate by yourself. I'm just showing you the process by which this can be done. When we want to calculate expectation of y square, then the same thing, same probability chart will be taken into consideration. The only difference is that the values will be squared in the following manner. Okay, calculate this. Whenever you will find time, you are going to calculate these quantities. And lastly, you are going to take, suppose this value is value 1 and this is value 2 that you have obtained. So to calculate the variance, we need to consider the following formula, which is value 2 minus value 1 whole square. So expectation of y has been calculated. Now, if someone tells you to calculate, this is my part 1. This is my part 1. So let me write over here. This is the part 1 that I wanted to discuss about the expectation. Part 2, I'm going to calculate the expectation of the random variable x1. Now, what are the probabilities that are associated with x1? What are the probabilities that are associated with x1? X1, this random variable x1, also have got 6 values, 1, 2, 3, 4, 5, 6. Okay, but if I look at the chart, this column totals, these column probabilities are the probabilities associated with the random variable x1. So when we want to find the expectation of the random variable x1, we need to consider these column probabilities. So in this particular case, the expectation will be calculated in the following manner. Since all the column probabilities are same, so you can take the probability common and you can write 1 plus 2 plus 3 plus 4 plus 5 plus 6, and then you can calculate this expectation. Now, after this, what we can do is that we can calculate the expectation. We can calculate the expectation of the random variable x1, x1, y1, x1, y, which is the joint probability, which will give you the expectation of the joint distribution. So that can be, what is the, so we need a formula for calculating this quantity. So how to calculate the expectation of the joint probability distribution. Okay. So, okay. So first of all, I'm going to activate the chat box where you can put your attendance. Put your attendance over there so that I can save it in time. First of all, I'm going to calculate the expectation corresponding to the joint probability distribution of the random variable y and the random variable x1 together. So I'm going to do this in the next page. So it is my part 2, this is my part 3. So in part 3, we need to calculate the expectation of x1 and y. So how can we calculate these expectations? So we have to consider the we have to consider the chart and we have to think which probabilities that we need to consider to calculate the joint expectation. So the joint expectation can be considered in the following manner. Just a minute, let me think. So we can do that x1 and so joint random variable. So to calculate the joint expectation, we will name it as joint expectation of the random variable. We have to consider the pair of random variables together, isn't it? We have to consider the pair of random variable together. So in this case, what we can do is that what are the joint pair? Joint pair is, if I consider the joint pair to be 1, 1, its corresponding probability is 1 by 36. If I consider the joint pair to be 2, it's 2, 1, its corresponding probability is 1 by 36. And in this manner, we can calculate the joint probability. So what am I going to write? Let me think a little bit. Meanwhile, you just put your attendance. I want to think that how am I going to write these joint probabilities? So in joint probability, we need to consider the random variable values together. That is the main important, that is the important point. The question is, how am I going to do it? Do this particular thing. Now, actually, what happens is that whenever we talk about the joint random variable, say for example, expectation of x, y, we consider the value, we consider the double sum. If it is a discrete case, we consider the double summation. We take xi and yj, and we consider the joint probability where capital X takes the value xi and capital Y takes the value yj. This joint probability is considered. And we take the product of the variables, individual values of the variables, that is capital X and capital Y. So suppose we have the value x1. So suppose we have the pair. So I'm going to calculate this quantity for the first pair. Suppose x is 1 and capital Y is 1. So, sorry, I'm going to write it as x1. And therefore, the joint pair x1, y, that would be 1, 1. If it is so, then the expectation, you know that the joint probability that x1 is equal to 1 intersection y is equal to 1, that joint probability from the chart, it's known to you. This is how much? It is 1 by 36. This is the joint probability. So we're going to write the joint probability here as 1 by 36. And if I try to apply this rule for calculating the expectation of 1, 1, only this I'm taking for the time being, then according to the formula, that should be equal to 1 into 1, because you have to multiply the value of x and value of y together. So 1 into 1 multiplied by its joint probability, that is 1 by 36. So you have got the expectation of 1, 1 as 1 into 1 by 36. Now suppose you are going to calculate the expectation of 1, 2. Now x1 is 1 and y is 2. So in this particular case, what we want to do, we first of all we will multiply 1 by 2. That is for sure, because of this rule. We are going to multiply 1 by 2. And we need to consider the joint probability when x1 is 1 and y equal to 2. And that joint probability is how much? x1 is 1 and y equal to 2. x1 is 1 and y equal to 2. That probability is how much? That joint probability is also, is it 1 by 36? Y equal to 2 is coming for two different values. It is 1 and 2. So my 1 and 2, x1 is 1 and y is 2. So we'll multiply these two value and the joint probability is 1 by 36. Yeah. The joint probability is 1 by 36. And we're going to write it as 2 into 1 by 36. Suppose in this manner, we are going to calculate the probability that the expectation that the joint probability or expectation of the random variable 4, 4, the pair of random variable 4, 4. So in this case, what we are going to do, we can multiply the two values of the random variables 4 into 4, and let us try to find the joint probability for this case. So the joint probability in this case would be for the point 4, 4, this is 4 by 36. This is the joint probability. So we are going to write it as 16 into 4 by 36 and so on. So I'm not going to calculate all the probabilities. It will just kill the time. Just you have to keep in mind that this is the form. That's why I was thinking, what am I going to write over here? Because it was going to be a very big expression. I was thinking that how to show the calculation to you. So the fundamental part is this one, that you need to consider the formula which is represented over here. This is the formula that you have to consider to calculate the expectation of the pair of random variables. First, consider the value of the random variable which comes first and the value of the random variable which comes second. Multiply them together and consider their joint probability from the chart. Multiply, calculate all the expectations and take the summation. So therefore, the double summation have been taken into consideration. If it is a trivariate distribution, 3 summations will be taken into consideration. So you are going to calculate this particular expectation in a similar manner. And another thing that you can calculate from here is the covariance x1y, which is expectation of x1y minus expectation of x1 expectation of y. I'm going to talk about the covariance part in the next session of today's class.